So good morning, everyone. My name is Jasmina Rinkovec, and I'm working on the environmental hygiene unit here at the Institute. So the definition of air pollution, according to the International Organization for Standardization, is that air pollution is the presence of substances in the atmosphere resulting either from human activity or natural processes in sufficient concentration for a sufficient time and under circumstances which have an impact on humans, their safety and health, and or the environment. So let us see what that really means. So there are two types of air pollution sources, natural and anthropogenic. Anthropogenic is really the human activity. So the natural sources could be volcano eruptions, sea salt, dust storms, wildfires, and the anthropogenic sources are, of course, the traffic, then industry, agriculture, and the heating system in households of cities or other settlements. So, how did we get here? I mean, do you know when did human first made the air pollution? So what was the discovery that come up to this? What do you think? No. So the first one was the discovery of fire. So when we discovered fire, the main energy source was wood. With wood, there came the pollution of black smoke. After that, we replaced wood with coal, and we get another kind of pollution like soot and sulfur dioxide and ash. But with that also came the rapid development of crafts and industry. And after the coal was replaced, not entirely, but with the discovery of oil, and this also conducted the development of the chemical industry and motor vehicles. All of these development processes also are, with all of this, we also got greater and greater settlements. So with all of this, more and more pollution were put in the air. So what did happen? That in 1940s and 50s, there was an episodes of smog in Los Angeles and in London, and that is because the people, and that is why people got forced to take organized action to protect the health and the environment. Let's talk something about the air pollutants. It can be gases and particulate matter. The particulate matter or aerosols can be of natural processes like sea salt, pollen, or spores, something like that. But the main harmful effects come from the processes made by humans. So, sulfur dioxide, the sources can be volcanic eruptions and burning of coal and oil, and it has a short-term exposure in decreasing the lung function and capacity, increasing airway resistance, and that could lead to difficulty breathing or shortness of breath. And in long-term exposure, the sulfur dioxide with some other pollutants can affect an increase in mortality, like total cardiovascular and respiratory, and it can increase the emergency admissions for respiratory problems. and chronic obstructive pulmonary disease. Sulfur dioxide is a primary pollutant. That means that it is emitted in the air directly. And the secondary pollutants are the pollutants that are formed in the atmosphere. So I'll talk about some other pollutants, so you will see the difference. Next one is nitrogen dioxide. The sources are product of soil, bacteria, combustion of fuel, chemical industry, exhaust gases, households when using natural gas. The health effects, the short-term exposure, are the reduction of lung functions and increase in bronchial reactivity. And in a long-term exposure, it could be susceptibility to viral and bacterial lung infection and the risk of respiratory diseases in children. And this is also associated with an increase in people suffering from allergies. So, next one. Next one is ozone. I'm here talking about the ground level ozone, not the stratospheric one. So it is formed indirectly by the action of sunlight on nitrogen dioxide. And these photochemical reactions are repeating as long as there is sunlight. So what do you think are the concentrations of ozone higher in the summer or in the winter time? Okay, yeah, because sunlight, summer, yeah, great. So in the air polluted with hydroxyl radicals, carbon monoxide and volatile hydrocarbons, the balance shifts toward the higher ozone concentrations, but simultaneously it comes with a higher increase of nitrogen dioxide concentrations. So that is how the photochemical smog is formed. It damages all parts of the respiratory tract and primarily affecting the airways and lung alveoli. Ozone can cause coughing and sore or scratchy throat, make it more difficult to breathe deeply. It can inflame and damage the airways, make the lungs more susceptible to infection, and increase the frequency of asthma attacks. Particulate matter. Particulate matter is a complex mixture of various organic and inorganic compounds suspended in the air in some amount of time. It could be hours, days, weeks, months. It differs in size, density, composition, shape, and origin. The sources of particulate matter could be scattered sea salt, dust blown by the wind, burning of fossil fuels, households, agriculture, and so on. The chemical composition of particulate matter is dependent on the location of sampling, the distance from the source of pollution, meteorological conditions, the presence of gaseous pollutants, oxidants, and so on. The main components of particulate matter are metals, organic compounds, materials of biological origin, ions, adsorbed gases, and carbon. We have total suspended particles, which are the particles up to 100 micrometers in diameter. And we have fractions of particulate matter like PM10, PM2.5, 1, 0.1, and so on. What is these fractions of particulate matter were put here so that we could study how they affect on human health, because the larger particles that do not enter the organism, but this smaller one does. So PM10 is the fraction of particulate matter with aerodynamic diameter less than 10 micrometers. PM2.5 is the fraction of particulate matter with the aerodynamic diameter less than 2.5 micrometers, and so on. So they had to say what is that aerodynamic diameter of this particle in question. So it is defined as the diameter of a sphere whose density is 1 gram per cubic centimeter and which settles in still air at the same velocity as the particle in question. So we have here filter. This is the medium on which we sample particulate matter. So this is before sampling, and this is our sample of particulate matter. We take this, and the mass of the particles is determined gravimetrically. Why does this size matters? So I don't know if you see, but this is the relative size of particles compared to the human hair. So the PM10 particles is here, and it contains all the particles that are smaller than 10 micrometers. So here you can see the PM2.5, and this one contains all the particles that are smaller than 2.5. So what do you think? Are the concentrations of PM10 higher of those of PM2.5 or lower, or it depends on something else? If we are comparing just these two, PM10 and PM2.5. Okay, so PM10 contains everything from 2.5 less and everything in between. So PM2.5, just this one. So the concentration of PM10 is always going to be higher than PM2.5. If you see anywhere that concentration of PM2.5 is higher than the concentration of PM10, something's wrong. Okay, something is not good, and it needs to be dealt with. Okay. So this is the picture where you can see where the penetration of particles into body can be. So the particles less than 10 micrometers can get to the upper respiratory tract. The fine particles of 2.5, less than 2.5, in the lower respiratory tract. The alveoli, in the alveoli can get the size of particles less than 1 micrometer, and the particle fraction of less than 0.1 micrometer can get into the bloodstream and with that into the whole body, carrying all the pollution with it. Okay, so elemental and organic carbon. So carbonaceous content represents a sizable fraction of PM10 and PM2.5 in particles, representing 10 to 40 and 20 to 78% of their masses respectively. The sources of elemental carbon, it is only primary pollutant. So from generally any incomplete combustion processes, either of anthropogenic or natural origin, and like diesel engines, domestic heating, vegetation, fires. OC, or organic carbon, may be emitted directly in the particulate phase, so it can be primary organic carbon from fossil fuel emissions, biomass burning, or biological particles, plant debris, or it may be formed from gas to particle conversion processes in the atmosphere, so then it's called the secondary organic carbon. Elemental carbon is a good tracer for emissions from fossil fuel combustion, namely urban emissions from road transport, because it is the primary pollutant. So we have the organic carbon and elemental carbon ratio. It can determine the emission and the transformation characteristic of carbonaceous aerosols. What that means is that if this ratio is exceeding 2.0, that indicates the presence of secondary organic carbon. This is the picture of the OCEC aerosol analyzer from our lab. Anions and cations. The sulfate, nitrate, and ammonium are the dominant secondary species Although these ions may be directly introduced in the atmosphere, but most considerable that contributions are produced by chemical reactions. Also, these water-soluble ions are a significant component of atmospheric particles. Also, the ratios of anions and cations are specific to certain sources, and their ratio affects or determines the acidity of the aerosols, thus impacting on their bioavailability, but also the bioavailability of other pollutants. So now we are coming to the polycyclic aromatic hydrocarbons. They occur in the atmosphere as a complex mixtures of congeners with different molecular weight. This one with the low molecular weight of 2 or 3 aromatic rings are present almost exclusively in the vapor phase, and those with high molecular weight, 4 and more aromatic rings, are totally absorbed on the particulate matter. Sources of PAHs are forest fires, volcanic eruptions, motor vehicles, residential wood combustion, fossil fuel, and industrial activities. So, according to the International Agency for Research on Cancer, the PAHs can be cancerogenic for humans or animals, and benzoylpyrene is classified as a cancerogen for humans. Metals, sources of metals can be industrial activities like mining and fossil fuel combustion, traffic emissions, not only vehicle exhaust, but the products of wear from tires, brake linings, impurities derived from fuel additives, and also natural sources like minerals, forest fires, and oceans. These are just 4 mentioned metals that are being monitoring as the air pollution, but it can be determined a whole other array of metals. Health effects, they cause a myriad of human health effects, so they are contributing significantly to adverse health effects, even at these low concentrations found in ambient air. According to the International Agency for Research on Cancer, nickel, arsenic, and cadmium are in group 1, so they're carcinogenic to humans, and lead is in a group 2A, which is a probable cancerogen. This is a health risk assessment, just one slide. I think I could talk about this whole presentation for half an hour. I'll just say something a little. So, average daily intake. So, to calculate health risk assessment, you need to take like models. So it's not the same if you're doing this for children or for adults. It's not the same if you're doing it for residential people or the workers in factories. All these variables you need to determine and say before you're calculating for who you are doing it. So these are the formulas for the average daily intake for the inhalation. So concentration you take from the pollutants depending on which you are wanting to calculate the risk. Inhalation rate, it differs on adults and children. Exposure time, frequency, duration, that's everything you need to determine and say what it is. Body weight also, and averaging times, it depends if it's the lifetime cancer risk, you want to calculate all the hazard quotient. These two, reference concentration and inhalation unit risk, you can get from this table at US Environmental Protection Agency. So you need this, so you could calculate the non-cancerogenic health effects of air pollution. So there are 2 types, non-cancerogenic health effects and cancerogenic health effects. So when you get the number of hazard quotient. The allowable non-cancerogenic risk is below 1, so the unacceptable value is greater than 1. That means a higher probability of developing non-cancerogenic impact on humans, so the actions should be taken to make it less. For the lifetime cancer risk, when you calculated it, usually the acceptable risk level is to be 1 additional cancer case of occurrence in the population of 1 million people. If it's higher, the actions need to be taken. So, okay. Now I'm just going to tell you something about the measurement methods. There are classical or manual methods with active and passive sampling, automatic devices, sensors, which can be remote and newer these low-cost sensors, and bioindicators. So active sampling is just a process of passing a known volume of air through a sampling medium. Sampler is consisted of inlet, pipe, sampling medium, the regulator and flow meter, and a pump. So sampling medium can be a solution, chemically impregnated filter paper, or just filter papers. It depends on the pollution you want to sample. So these active samplers can be on different processes like chemical reactions, absorptions, adsorption, impaction, filtration, diffusion, or even the combination of these processes. What are the advantages? It's relatively low price, it's easy to handle, and you can get the daily averages, so you can compare it to something in the past and now. The disadvantages are that they need the source of electricity, and the samples need to be need the subsequent analysis in the laboratory. The passive sampling, that are devices that collect pollutants in the air using absorbent material without the use of pumps. So they are working on the principle of free diffusion or diffusion through a semi-permeable membrane. There are practically tubes with one open end, or they can be like a badge type. The open end is protected by a membrane filter or other windscreen, and the closed end contains an absorbent for the gaseous compounds. The advantages of these samplers is that their simple design, low price. They do not require the source of electricity. They can be placed in a large number of places, and they are particularly suitable for monitoring personal or professional exposure. The disadvantages of these samplers are a high detection limits and poor precision, and they are not suitable for daily sampling. They need a longer periods of time to sample a substance. And also, they also need a subsequent analysis in the laboratory. It is a good screening method, in particularly polluted areas near local sources of pollution, or it can be placed to monitor concentrations at the remote locations. Automatic devices, they have a different measurement techniques, which depends on the pollutant you are trying to determine. They also have the automatic monitoring of meteorological parameters, UV radiation, motor vehicle frequency monitoring, and so on. And they are very good in control of industrial emissions or processes. And these instruments need to be regularly maintained. So what are the advantages and disadvantages of these devices? The advantages is that they have a high accuracy, precision, and effectiveness with a low detection limits, and they enable obtaining a minute values and hourly averages, and they can online monitoring of the information. The disadvantages is that this is a complex and expensive equipment. It is not suitable for testing personal exposure of people or for routine research involving a large number of monitoring stations. It does need electricity and special conditions like a lot of space and air conditioning, and some of them do need the daily maintenance. This is just a table with the overview of methods for measuring air pollution. So here are the pollutants, and here is the method they are being determined by. So sensors, we have the remote sensors. Those are the instruments that use long path spectroscopic techniques to allow real-time monitoring of concentrations of different pollutants. Advantages are that they can be placed in hard-to-reach places close to the pollution sources, and they are enabled to do the multi-component analysis. The disadvantages is a very, very high price and complexity, and it's difficult handling, maintenance, and calibration. So it is mainly used in some specific scientific research, and one of the examples of these remote sensors is this differential optical absorption spectroscopy. Low cost. So do they offer the air pollution monitoring at a lower cost than conventional methods, making air pollution monitoring possible in many more locations? So this would be great, but unfortunately still it isn't like that, because the measurements are often of lower and more questionable data quality. So disadvantages are that they are sensitive to weather conditions like wind speed, temperature, and humidity, and sometimes they have difficulties distinguishing the pollutants. So measurements with sensors should be carefully evaluated and validated. And if there is a correct data, it is a representative for a very small area. But if they improve the quality of measurements, and they're really trying to do that, this could become a game changer in monitoring air pollution, traffic management, personal exposure and health assessment, citizen science, and air pollution assessment in developing countries. That is an air quality monitoring using living organisms, most often plants and lichen or lichen, I don't know how do you want to be said. So the passive biomonitoring, there are organisms that grow naturally within the area of interest, and active biomonitoring is that you place a test organism of known response and genotype. And the advantages are that they have direct assessment of the risk exposure and indications of indirect and immediate risks for animals and humans. And the choice of bioindicators depends on the climate of the studied area, and these indicators need to be highly sensitive to certain pollution so they could have a specific response on it. The disadvantages are that this is limited due to the lack of standardized and validated methods and the lack of threshold values and other standards. Why is this important? Because the methods of measuring individual air pollution are strictly defined so that the results measured in individual cities and countries can be compared with each other.